wonderful good morning to you. So I hope you're feeling fine. You had your first, second, and at least third coffee today. And yeah, we're starting to create an MCP thingy because MCP is hip right now and everyone's doing MCP. And there is a whole lot of MCP servers around, but very little MCP clients because everyone is providing you an MCP server because it's very simple to create one. And yeah, today we will have a look at how to create a server because it's easy and how to consume a server because it's easy as well. And yeah, what's the hype all about? Who is already using MCP servers of you? Okay, at least a few. So Chrome DevTools is providing you an MCP server, or Playwright is giving you an MCP server, or Angular is giving you an MCP server, which is cool. Okay, so it all boils down to context engineering. Because MCP is a solution for the context problem of LLMs. So it solves a certain problem that comes with the architecture of the big and small language models. That's me. And today we will cover some basics that are necessary to understand why MCP makes sense. Then we will have a brief look at tool calling, because that is the core functionality of MCP. And then we will cover MCP clients and MCP servers. And we will have a look at different transport mechanisms that MCP is specifying. So there is an initiative, an official initiative. You can find it at modelcontextprotocol.io. This is the official website of MCP. There you get a ton of resources. You get a list of popular MCP servers. You get links to the SDKs for MCP. There is an SDK for JavaScript and TypeScript and for a whole lot of other languages. So it's not limited to a certain language. It's more of a concept, and it specifies some framework rules that the SDKs should align with. But yeah, it's more an overarching concept. Okay, some basics. I'll make it very quick. So LLMs are at their core stateless. So they keep forgetting what you tell them until you deal with their memory. So if you start an LLM, or talking to an LLM locally, for example, there are different platforms, such as Ollama, which I'm using. So I'm a model Messi, as you can see here. I take this model here. So if you run this model, then it gets loaded into the memory and you can talk to the model. And if you talk to this model via its interface, then it creates tokens, it answers to your questions or to your prompts. And if you then rerun a prompt, it forgets what it just told you. So the answers are by default always different. You can come by this problem if you do memory management on your own. So you send the whole conversation history to the model and then it remembers everything. but the brain of an LLM like this is rather small. It just covers a limited amount of tokens, and if your conversation exceeds this amount of tokens, then it just keeps forgetting things again. Speaking about the memory of an LLM, there are different sizes. The default models or the smaller models right now have around 128K tokens, which is a fair amount because one token is 3/4 of a normal word. There are websites like the OpenAI tokenizer platform. Could you increase the font size? Yes, of course. So here you see how a sentence is broken down into tokens. In my example, it's broken down word by word, but if you take a normal German word, like this, you see this word, which means captain of a steamboat at a big river, is 15 tokens. So it depends on the language, on the words you're using, on the platform you're using. Currently, we're using the GPT-4o tokenizer, which is different to the GPT-3 or the GPT 3.5 tokenizer. So they're all different, and you have to deal with tokens all the time. So in our case, a standard model has 128,000 tokens of memory, which is a lot, but more modern LLMs have bigger context sizes, like Gemini 2.5 with 1 million tokens, Llama 4 with 1 million tokens, or GPT-4.1 also with 1 million tokens. There are some Google models that exceed this number with 2 million tokens, which is very, very big, but you see the last column, the effective context size is way smaller. What does effective context size mean? You can only use a fraction of the whole context efficiently. So you can put everything in the context, but the LLM uses only a fraction of this context to remember things very precisely. The more data you provide the LLM, the more diffuse the response will be. So although you have 1 million tokens of context, you can only use 2,000 tokens to create high quality answers in Llama 4, for example. GPT-4 is much better. It can use 16,000 tokens, but compared to an overall size of 1 million tokens, it's nothing. There is a paper and a testing tool set called NoLima, which is able to measure the effective context size of every given model. So you can clone this and run it, and there is a step-by-step guide. So if you're a little bit bored, then just try out some models. It requires some resources, so you have to have at least a big gaming computer to run this. But if you're interested, the link is in the slides. Okay, so we have to deal with context, which is very important. There are different strategies, so you can reduce the context size by summarizing things with a specialized LLM for that purpose, and stuff to come by this shortcoming. There is also the use of MCP to work with the shortcomings of LLMs because MCP is able to provide you precise information that you can create your context of and give the LLM the information it needs. There is another problem. So there's a whole lot of problems when dealing with LLMs, and one of the major problem is the knowledge cutoff. So the LLM only remembers things it was trained on. So the training is at some point done, and all the events that occurred in the time past the training are not available in the LLM. Also, private data or any data that was not available when training the model, so hopefully your social media data and stuff like that, are not part of the model, and therefore you cannot question the model for some specific company-related information. And this is also something that you can solve with MCP or with tool calling by providing the LLM specific information for a certain question. So speaking of tool calling means the LLM is able to call functions. So you provide an LLM a function, for example, addition. So LLMs are not good at math. So you can create a function that is doing some very specific math. For example, add two numbers, which is not higher math, but you can add or you can provide this LLM this function and tell the LLM, hey, if you face the problem of adding two numbers, please use this function instead of your own brain and provide me two numbers, and I will add them for you and give you the result. This is a very simple example. You can also get stock values or the current weather or whatever you can imagine. You just have to define your function, describe your function, make it available for the LLM, and then it is able to call it. I just prepared an example. I created a very simple tool that is able to convert euro in US dollar. So this is my tool. It's called Currency Converter. It's an asynchronous JavaScript function which does all the magic. It has a fixed conversation rate, and it needs the currency which is the basic currency and the target currency and an amount. And then the model is able to do currency conversion. So this is the function implementation. The second part of the tool specification is a configuration object. The name of the tool, which is very important because that is the reference the LLM is using when it wants to call the tool. Then a brief description what the tool does. This is a very simple tool. It converts euro to US dollar or US dollar to euro, and it needs a schema. In this case, we're using Zod to define the schema. Zod is a schema validation library in JavaScript, very popular one. And we're defining the schema very precisely. So we're allowing input or from US dollar or euro and to, so the target currency, US dollar or euro. We can improve this schema, so it's not possible to convert US dollar to US dollar, but it's fine for the moment. And with this information, we can feed our LLM and register the tool and tell the LLM, hey, if you face the problem of converting one currency to another, use this tool. The implementation looks like the following. So it consists of multiple parts. It looks horrible, but it's easy to explain. So first of all, we have a model instance, because we need to talk to an LLM, because in any other case it wouldn't make any sense. Then we have our tool. The tool definition is done with, in my case, with the tool function that comes from LangChain. LangChain is a library for JavaScript and Python, which makes some things easier. For example, tool definitions. So we're registering the tool and create an agent. Everything that has something to do with an LLM is an agent. So yeah, take that for granted, but please don't ask. So we're creating an agent. It receives our model instance. In my case, it's a very small one. It's a llama 3.21 billion parameters, because that's quick. Then we register our tools. In our case, it's only one tool, but you can register as many tools as you want. Then we create a system prompt and tell our model, hey, you're a helpful assistant. So a useless assistant wouldn't make any sense. But, and here comes the important part, you can use tools if you need them. The ability to call functions is built in to your model. And if you choose a certain model, you have to be very careful that it supports tool calling. So I'm using the Ollama platform, which is a local platform that executes LLMs. And it has a model registry, and you can look for models. So for example, the IBM Granite model, version 4, which is the latest one. And here you see, or you don't see, it is able to call tools. So it's a flag for the models. Not all models support tool calling. So be careful that your current model supports this. If you're using a commercial one, like GPT or Claude or whatever, they all support tool calling, so no worries. So this model supports tool calling in all of its sizes, so you can either choose a smaller one or a bigger one. All of them support tool calling. And the same is true for my small Llama 3.2 model. So I'm hinting my model, because a small model is sometimes very stupid. So I'm giving it a hint, hey, you are able to call tools and I register tools, please use them, please. And sometimes you need to be very precise that the model is doing the right thing. So this is the preparation. Then there is some Node.js code because I want to interact with my model via the console. So I'm creating a readline interface in an endless loop, and I'm prompting the current user, so me, for input. And I'm sending this input via the invoke function to my agent. So this is the core of my LLM application. So I'm prompting the user, sending the input to the model, and console logging the result. So we can try this out. MCP code 01. No, not inspect, but index. I have 100 euro. How much is this in US dollar? So it takes a while, and it is approximately 117.65 US dollar. You can see it always answers slightly different, but the result should always be 117.65 US dollar, because that is what my tool answers. if I answer with a random number, it will always be different. We can check this out 10 times, and 8 times will be fine, and 2 times it will screw up totally. So now it starts to hallucinate a little bit, because €1 is 1.10 US dollar. So you have to be a little bit careful. This is because we're using a very small model, and it's very creative. So you can see it's always, now the exchange rate is 1.13 US dollar. So you have to limit the model's answers very explicitly, because it's doing strange things. So this is a thing you have to be very careful about. But we have a solution within the MCP scope for that. Okay, enough about tool calling. So let's end this, and let's continue. So tool calling. This is the basic of, or one of the basic ideas behind the Model Context Protocol. And the idea of the Model Context Protocol, which was invented by Anthropic, which is a company that provides LLMs, but they said, hey, let's create an initiative which is not company related, but for all of the providers and all of the software engineers and all of the companies worldwide that have to deal with LLMs, and give them a standard way of creating APIs that enable LLMs to work with external data sources. So this is the core idea, to provide an API that is able to decouple certain functionality of your application from the actual LLM. MCP in its core has nothing to do with an actual LLM. So the LLM does not execute MCP or implement MCP or whatsoever. It's just a protocol. It helps you if you create an application or a server or provide some functionality to do it in a standard way. And that's it. Nothing more, nothing less. You can create MCP without an LLM. That doesn't make that much sense, because then you have just an JSON RCP service. But the idea behind is just that. You provide an external API that is callable. There are 3 different roles in MCP. There is the host application, which is your own application. In our case, that was the command line interface application. This is the host. The host talks to the LLM and implements the client. The client is a regular client that talks to the MCP server, and the MCP server provides functionality. 3 clearly separated topics. And there are 3 core concepts. So the number 3 is going through the whole MCP. No, it's not, because we only have 2 transport layers left remaining. But it once was also 3 transport layers. So in MCP, we have the most important thing, which are tools. Tools are callable functions that provide you functionality that can be read or written or modified or whatever. Then you have resources, which are usually read-only data. So if you define a resource, you shouldn't have any side effects. And then you have prompt templates. The MCP server provides you configurable prompt templates that follow some best practices of the MCP server provider, and that gives you a predefined prompt that you can use to interact with your LLM. So in these 3 concepts, you don't directly interact with your LLM. You just use them for your own interaction. Technically, you have host, client server, and the client communicates with the server. And you have two different transport mechanisms. The first one is STDIO, which stands for standard in and out. So this is on a process level, and this is why this transport is used locally only. So you can download any MCP server, install them locally on your machine, and you are able to talk with process standard in and standard out between the client and the server. The second one is a remote available transport, which is streamable HTTP. Yeah, it's using the HTTP protocol, just like our browser, to communicate remotely between a client and a server that decouples client and server from each other, and you can set up a centralized MCP server, and all of your clients can talk to one server instance with authentication and all the stuff. So everything is solved already in the concept of the MCP, and you just have to do the implementation or use the SDK and let it help you. Okay, so first example, we're doing tool calling with MCP. First step, define a tool in the server, then wrap it around in a server instance, then define a client and talk to the server. Luckily, I've prepared something for you. I'm using the Model Context Protocol SDK in a raw version to demonstrate you the bits and pieces, and we're improving that implementation step by step until we reach a fully functional remote MCP server. So first step, lock the screen, which is a good idea. First step, we're defining the server. This server looks like the following. So if you remember the implementation of my currency converter, this is very similar. So I'm creating a new MCP server instance, which is the wrapper around the whole thing, and then I register tool, which is similar to the tool function which we had previously. We give it a name. So my tool is called distance. The distance tool calculates the distance between two cities. We create a schema, also with ZOT. We require a city A and a city B, and we calculate the distance between the two cities. Our distance calculation is very simple because it's just a random number. But it's fine. You can do everything you want. As you see in line 19, it's an asynchronous function. So you can call a web service. You can talk to the database. You can talk to the file system. You can implement some algorithm or whatsoever. So you're completely free what you want to do there. You create a response. In our case, it's very synchronously because we just create a random number and return the value to the calling instance. You can delay it by some time. So, for example, we can do something like await, set timeout 1 second, which simulates a server call or whatever. And we need to import it from Node.js. So this is just a time delay in the response, if we want to simulate something. So next step is to wrap it in a transport layer. So this implementation is completely independent of the transport layer. So we can decide if we want to use a local communication, which is very fast, between standard in and standard out, or we can wrap it into a remote server with streamable HTTP. The implementation is, as I said, independent. So we're heading over to index.js file and use the stdio server transport, which is provided by the Model Context Protocol SDK, which is the local communication infrastructure. And this wraps our server. At that point, we decided our server implementation and the connection to the client. So now all is set and done. And in the next step, we can use this server locally in our application. There are different possibilities to use this. So this is the preparation. We need a transport instance. In our case, it's the standard in and out. And on top of that transport layer, we create a new client. And then we connect to the server. And at that point, we can use our local server. You can either call the tool directly. So if we want to know the distance between Berlin and Munich, for example, we can call the tool and we get a result back. Or what is much more interesting, we can list the capabilities of our server. With list tools, you get a list of all available tools and their description and their schema. So let's run this first. And we call the client JS. So this is a very readable version of our tool description. You can copy it and beautify the code. Make it beautiful? No. Okay, so this is the tool description that is auto-generated by our MCP server, and this is the description we can use to call the tool. If you have multiple tools, you get an array of tools and all of their descriptions and use them. Now, next step, we want to call the tool and see what's happening. And we want to know the distance between Munich and New York. So call the tool, name distance with arguments city1 and city2, and get back the result. No LLM involved here. That's just a remote procedure call. It gets much more interesting, but for the time being, we're just calling the tool. And you see the distance between Munich and New York is 629 kilometers. No, but a random number. And now it's 89. So the two cities are growing together. So this is implementation specific. But it shows you the core principle of MCP. You have client, you have server, and the two of them communicate together. And this answer here can be put into the context of your LLM in order to give you a good answer. So you remember currency conversion, and now we can take this and give our LLM the ability to answer the distance between whatsoever city on the world and improve the functionality of our very, very small language model, which is cool, with very small impact and not that much code. Yeah, so this is the first step. This is tool calling. Next step is, of course, the other two. So we integrate a resource in the next step. No, we don't. There are two things worth mentioning. If you have a look at this is a little bit horrible for me because that creates a new process. It calls Node.js, and a file. So it executes the server on its own in a child process and communicates, as the name of the transport suggests, with standard in and standard out. So this is responsible for creating the server. So the client spawns the server because of the transport mechanism. So if you browse the internet, find a very interesting MCP server and include it in here. What is the problem? You can crash your server. Yes, either your server or your local system, because it's not limited to development purpose, because my grandmother is able to download an MCP server from the internet and wire it in her Claude UI or whatever. So this is very, very dangerous, because it's just executing a remote script downloaded from the internet. What could possibly go wrong? So please be a little bit careful, because you're executing stuff from the internet. Okay, let's execute stuff from the internet. I've prepared something for you. So this is a very simple example. I created a new folder called external server. You'll get the source of all of this to play around with it. So I downloaded a tool called MCP time server. And by the naming of the thing, you can see it's a Python code. So it's just a Python script that gives me some time-related functionality. This is just a demo MCP server, but you see how you can use it, and it's written in different languages. So we're using a Python MCP server from JavaScript, which is cool. So we're using the standard I/O transport. So we're creating a new Python process with sources downloaded from the internet. Create a new client. Create a new client, wire it together, and then list tools and call a tool called get current time from Europe Berlin. Now we can execute it, and hopefully my system doesn't get deleted. So you see this. These are the available tools. Where is my JSON file? Here it is. So get current time, convert time, and that's it. So 2 tools which can be used. We decided for one tool. We're using the get current time for a certain time zone, and we call this thing, and the tool result is time zone Europe Berlin. Date time is today 11:08. It's Tuesday, and is DST false? Yes. So the result is correct. And yeah, that's it. So it's that simple. Look for an MCP server, download it from the internet, execute it, attach it to your application, and use it. And with this result, you can feed your LLM and make it more smart. That's it. And this is true for every given MCP server. Okay, next step. We want to deal with resources. So I'm creating a new MCP server. So to keep things as separate as possible. So first step is to create a new resource. So we're creating a resource called cities. And a resource is something like REST endpoint. So we're defining a resource. In our case, we have the protocol cities, and we have a variable called country. And we can provide any supported country and get a list of the biggest cities of this country. We're only supporting 2 countries. In our case, it's Germany and USA. You can extend that as far as you want. So this is the name of our resource. This is the description of the resource. So if we list the resources, we get this as a documentation. So our resource tells the caller what it supports. This is completely optional. You can also add undefined. So list is a mandatory field, so you need to define it, but you can provide undefined, and then you're not able to list any details of the resource and get only an empty array, which is frustrating. So we're providing a function that is creating a documentation, or at least some part of documentation. Then a brief description, or a title and a brief description, and then the implementation of the function. A resource is also a function. It's only the idea behind. So tools are read-write and resources are read-only. List of cities, database schema, the result of an SQL query or whatever. So you're not limited to anything. You should consider not having side effects in your resources, but you can do whatever you want. It's just a simple JavaScript function, and you're allowed to use any of Node.js, so anything. Okay, next step. We need to define the transport layer. Transport layer is again the same as we previously had. So we're just wrapping it into stdio. And then our client implementation is doing the same. So we're in the first step, we're listing the resources. So what is available? And let's have a look. You don't need to fire up your server because the client starts the server on its own. This is the documentation. You can see the title and then our documentation. We support cities USA and cities Germany somewhere. And yeah, that's basically it. Then we include the resource call. It's called read resource. You give it a URI to identify the given resource. In our case, we want to see the biggest cities of Germany. And then we call it and you see Berlin, Hamburg, Munich, Cologne, Frankfurt. We can change it to USA. And you see it's the cities of USA. So read-only resources, and the last thing is prompt templates, which follow the same principles. So you define a server. Now our server has tools, resources, and prompts. Independent of the transport layer, you see the code size grows a little bit. And yeah, our prompt is a little bit bigger. So it's a product description. It's a prompt template for a product description generator. And it generates a product description based on given parameters. Our schema is the product name. So we want to create a product description for an apple or something. And we need to provide the length of the description, so either short, medium, or long. And the result is Please generate a compelling product description. The product name is what we handed over. So for example, apple or banana or whatever. Focus on its general benefits and appeal. And then if we provided the optional length, keep it concise, around 1 or 2 sentences, 3 or 5 sentences, or provide a detailed description, potentially multiple paragraphs. So this is just a preparation of a prompt that you can hand over to an LLM to create whatsoever. This is specific for your MCP server. So for example, if you have some database in the background, you can provide the database schema via resource. You can prepare some prompt templates and then use a tool to get the actual data, and so you can combine the 3 elements of MCP together. You don't have to combine all of them. You can only add tools and everything is fine. So it's just up to you and up to what you need from your MCP server. So wrap it into a transport mechanism and create a client for that. So it just repeats itself. So the client, in our case, lists just the available prompts. I'm just feeling like a dentist. Okay, so we have a prompt template called product description. It's a product description generator with this schema. I don't paste it and make it beautiful. You can have a look at it later on. But what's much more interesting is the result. So we are creating a product description for Super Widget 3000 in a medium length. And the result is, please generate a compelling product description, product details. The product name is blah, 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 style and constraints. Aim a paragraph about 3 to 5 sentences. You can take this directly from the response, paste it into your LLM, and the LLM does the rest. Okay. Next step, we didn't involve any AI until we involved AI, but not for the last half an hour. So now it's time to involve some AI and make it a little bit more fun. So we want to create an LLM application. First of all, we're using our MCP server in a separate folder. Just give me a second. So server implementation is just what we had with a prompt template, with a resource, and with a tool. So this is the server. Then transport mechanism, like this. Nothing new, just wrap it into stdio. And now the interesting thing comes. We need to implement the host application, which is responsible for talking to the LLM and using the MCP client in order to talk to the server. So the most interesting part is the client implementation. And we're combining all the things we just had a look at. So from the basics, we're using an LLM. I switched from the very small model to a bigger one, the Granite 4. Here is something MCP specific, or we're using LangChain MCP adapters, which is a tiny abstraction layer which makes our life easier. So we're creating a multi-server MCP client, which gives us the possibility to register not just one MCP server, but multiple of them. Here are our MCP servers, they are following the same principles. So we're using a certain transport mechanism, which is stdio. We give it a command, node, index.js, which starts our local MCP server. We get the tools of it. We create an agent with the model and tools and a system prompt. You can use a tool to calculate the distance between two cities, and then our Node.js interface to interact with the LLM. So it's just the same building blocks, but arranged a little bit differently. The server and the server transport mechanism stays just untouched, and we can use it within our host application that now uses a tiny bit of LangChain to make it easier, because this deals with tool calling, because if we don't use this create agent thingy, we would have needed to call the tool on our own, which is a little bit annoying. So it makes our life easier. We head over to our application, node index.js. Yes, would you please do something? No? I just started the server, which doesn't do anything. I need to run the client. So how far is it from city? Any city? No city? 2? Okay. It's 40 kilometers, approximately. No, it is not. Now it's 29 kilometers. The distance from Chicago to New York. You see, it strongly depends on the model what response you get. So we changed the model from Llama 3.2 to Granite 4, and it just behaves differently. And there is 1,000 kilometers between Chicago and New York. I don't know how far they are apart. So based on our knowledge, this is just a random number. And it's just doing some strange things, not 17.5 kilometers. So it's just reasoning around, so I don't know. So local application with a local MCP server and a local model. You can change the behavior of all the single bits and pieces, so you can switch the LLM by just saying, hey, I want to use a different one. You're not limited to Ollama. You can change it to OpenAI or whatever. You just have to change line 22 to 25 to use a different model. You can add different MCP servers by registering and deregistering them here. You can switch the transport layer by changing line 13 from stdio to streamable HTTP. So you're very, very flexible, and you don't have to fiddle around with certain tools, but just tell your application, hey, here your MCP server is. The tool gets automatically registered, and you can just use them. The last step in our process is that we change the transport mechanism. So we're switching from local to remote. and our server stays just the same. So it's exactly the same implementation, no changes here. In the index.js from our server, there is a big change. We're using Express.js. We're creating an Express application. We're creating a post endpoint for /MCP. Add a new instance for streamable HTTP server transport. Connect the server to the transport layer and hand over our current request to the MCP transport layer. And that's basically it. So this is wiring our independent server to a different transport mechanism. You can add session handling, authentication, and stuff like that here. So this is the thing you need to deal with that. But for our simple, not authenticated, not session-based implementation, that's all we have to do. So we switched from local to remote. And now we need to start the server. Server is running in the background. Now we need a new console and the client implementation. Client implementation is very similar. So MCP server with a URL, that indicates we're now using a remotely attached MCP server. And then register the tools, pick an LLM, create an agent that is available or that is able to call tools, and then our host application implementation, which is a Node.js command line interface. Can be any web application or desktop application or whatsoever. And then we go there, Node client.js. Here you need to be very careful that your server is running in the background, because now the client doesn't spawn a child process, but relies on HTTP as a communication protocol. Client and server are now highly independent from each other. And now we can ask how far is it from Heidelberg to Wien? It's 887 kilometers. In order to debug this, we could add a console log statement in our server implementation in order to log out the distance it just generated and check if that was the value or not. Okay, so we covered quite a bit of topics. So we came from the bloody basics of context and stuff. We did tool calling. We implemented an MCP server with a tool, a resource, and a prompt template. We changed the transport layer from standard I/O to HTTP. And this is the end result. We have an independent application where we can switch transport layers, where we can integrate additional MCP servers, where we can switch the LLM we're using, so we're completely free of whatever we want to do. And this is the basics of MCP. And you can use either your own MCP server or use a predefined one. Any questions? Yes? So you want to list, you want to create an application with MCP, or you want to create an MCP server that gives you all of your employees. There can be different strategies. So if you only have a list of employees, that would be a classical resource. So list me all of my employees. If you want to filter them by office or something, or by their role, then you create sub-resources. For example, for the Berlin branch, you get employees / Berlin, and you list all of your Berlin employees. If you want to have a more sophisticated filtering algorithm or sorting or something, then you should consider using a tool, and you just describe the tool with additional filter options. So for example, filter by name or by role or by whatsoever, and the tool executes then the database query or wherever you store your employees and gives you back the result.
Tool executes it, right? For example, you have the model as well, and model doesn't kind of know that.
The model doesn't do anything. The model just tells your application, hey, dear application, I want to use this tool with this set of parameters. Your host application then talks to the MCP server and executes things. So the model is stupid. It can only tell you, I want to do this and that, and you're responsible for doing this and that. Any further questions?
Thanks for the great talk. I actually have 2 questions.
Yes.
Can you think of a good way how to automatically test the behavior, like instead of manually?
Oh, that's a good question. How to test an MCP server? That's easy because it has a very predefined behavior. So in the easiest way, you just write tests for these functions. You can execute them, and that's it. So it's if you want to test an LLM application, it's hell because an LLM just answers differently. MCP is predefined, it's solid, it's easy, it's perfect to test. For testing purpose, either use this directly or encapsulate it into a stdio wrapper and then call it directly. So it's perfectly testable.
But this would be unit test now and end test.
It would be unit test. If you want to do end-to-end test, you might have to mock your LLM. Or you be very precise in picking informations from your model's response. Second question?
It's the same direction, but how can you log it in production, like from end to end, like the user requests and see what happens? Do you use something like length?
Yes. Either you use an LLM infrastructure that is specialized on this kind of application, or you can even simplify it and use a reference number for logging purpose, and then you can filter it. Because it's just like a standard multi-service, a microservice application, and the MCP is just another microservice in your application. So the same architecture principles apply as in any other microservice application. When it comes to scaling, logging, fault tolerance, and stuff like that. Basically, it's just JSON RPC. No magic. Any further questions? Yes.
Thank you for the talk, Sebastian. In the beginning, you were talking about the effective context size. What are the best practices how to keep the context? So you get the best answers. How often should I clear it, or are there any other ways?
So there is So the question was how to deal with context. You know the context size. So it's 1 million or 128K, and you might know the effective context size, or you might not know it, but 4K or something is just okay. So try to keep the most relevant information in 4K or 4,000 tokens, and all of the rest can be summarized somehow and added to the context. So you have to play around with it a little bit, but try to keep your context as concise as possible, and try to summarize the history or put it into a database and pick the most relevant ones. So with a rec application or something. So there are different strategies. It's very dependent on your problem. Yes, one last question. Yes, then we consider it as one. So I don't know how to summarize your question, but I'd suggest to split your application in as good predefined parts as possible. So if you have one topic, put it into a module or an MCP server or whatsoever, because then it's encapsulated, it's defined, it's testable, and you can change the implementation. So just try to modularize your application and keep your host application as simple and as small as possible, because it automatically has the tendency to grow and become messy. And MCP gives you a chance to decouple the functionality of your application. I hope this answered your question. What was that all of your 2 questions, or was that just one? I'd put it into a separate service. So not leave any specific thing in your host application. Your rack system is a typical use case for an MCP server. And you can either decouple it with standard I/O transport, which is very fast, or make it available remotely. Then not only your chatbot can access it, but any other service in your company can access it. Okay, then thanks a lot. Manfred is getting a little bit nervous because I'm way over time. Okay, then thanks a lot. I will be around until Thursday, so if you want to talk, let's have a chat at the coffee machine. Thanks a lot.